This is a video on chapter 4, part 2, the last few questions for the notes. So for the first one, we've got a curve y equals to x plus 2x plus k cutting the y-axis at the following points, 0, -6. From here, we can do a quick sketch of this graph. If we multiply it out, we are going to get an x squared term, where the coefficient is positive 1, which means that we have a parabola opening upwards. So y equals to x plus 2, x plus k. And this graph cuts the y-axis at the point a is -6. So if the y-axis is over here, this must be -6. So if this is -6, then this must be our x-axis, which lies above -6. So find the value of k. We have one set of coordinates that we can substitute into this equation, where 0 is the x value and -6 is the y value. So let's substitute them into this equation. We get -6 equals to 0 plus 2, 0 plus k. This results in 2k equals to -6, k must be equals to -3. So this is for part A. Now part B, find the coordinates of the points where the curve cuts the x-axis. So we want the coordinates over here and over here. Knowing that k is equals to -3 helps us. So let us replace this with -3. When it cuts the x-axis, intersect x-axis, we know that y is equals to 0, because that is the line y equals to 0. So now we have 0 equals to x plus 2 and x minus 3, resulting in x equals to -2 or 3. So this coordinate, this intersection over here has a x coordinate of -2. And this must have the intersection, the x coordinate as 3. What this means is that the coordinates will be -2, 0 and 3, 0. And this makes sense because this is our y value, this is also our y value, and we know that the y value at these 2 points will be 0. It is the x-axis. And finally, we have to find the coordinates of the turning point. We are going to make use of the symmetrical property of parabolas in order to find our minimum point. So here we have the x coordinate and the y coordinate that we need to fill in. If we know one of these coordinates, we will then be able to substitute it back into our equation, where we now already know that k is -3, to get the other coordinate. So based on this, we can tell the midpoint, okay, the x coordinate first, by taking the middle of -2 and 3, because it is symmetrical. So the average or the midpoint of -2 and 3 will be, so right, x coordinate is equals to -2 plus 3. We are literally finding the average. We add them up, we divide it by 2. Okay, so 3 minus 2 is 1, divided by 2 is half. The x coordinate is half. Once I know the x coordinate, I can easily find the y coordinate. Sub into y equals to x plus 2, x minus 3 to get the y coordinate. So y will therefore be equals to half plus 2, half minus 3. And that results in -6.25. Okay, or rather -6 and 1/4. So the y coordinate will be -6 and 1/4. Practice number 2. Using the graph, okay, let us see what this graph is. Y equals to x squared plus 2x minus 1. I know it is a parabola opening upwards because the coefficient of x squared is positive. It cuts the x-axis at A and the y-axis at B. Find the coordinates of A and B. Okay, in my diagram, I don't have the point A and point B, but if your notes has point A and point B, you will be able to figure it out by simply substituting x equals to 0. So that is if you want to find the y-intercept. To find y-intercept, sub x equals to 0. Then to find x-intercept, sub y equals to 0. And for this, we are expecting two answers, where the smaller value will be over here and the larger value over here. Then the minimum point, again, we'll be using the symmetrical property. We are going to take the average of the two x-intercepts to get the x-coordinate of minimum point. So suppose it is x1. We're going to substitute this into the equation to get the value of y, and that will be the minimum point. Then finally, to find the value of p, we are going to substitute x equals to negative 2.8 into these parts, and we get the y coordinate.